Section 10-1, starring Sam McAdams,
What the heck, man?
Zach Peoples. I don't know, I just picked it random. Alright, anyway, here we go. Sequences. A sequence, again, is nothing more than a pattern. When it says find, actually, before we jump into the first few problems, you need to be aware of the terminology. Okay. A sub n is the formula for your sequence. So when it says find the first four terms, that's saying find a sub 1, a sub 2, a sub 3, and a sub 4. That is the first, second, third, and fourth term of your sequence. N, in this chapter, represents just the number of the sequence that you're on. Which is why it's important throughout this chapter that we're going to have a formula for finding that particular entry number. So all you have to do are plug the n numbers straight into the equation. So for number 1, a sub 1 would be 3 times 1 plus 2. A sub 2 would be 3 times 2 plus 2. 3 times 3 plus 2. And 3 times 4 plus 2. You just plug this number, the n number, into your equation. And that's it. That's all there is to those. You're going to notice little patterns. Number 7 and 11, you see how they say negative 1 to the n? There's only one point to have that in there. Who can tell me why they think negative 1 to the n? Why is that even in there? Seems like kind of a pointless thing. Yes, sir. That's right. The whole reason for having negative 1 in a sequence is just so you can change between negative and positive. Give it that trigonometric effect of bouncing back and forth. In fact, not in this chapter, but in calculus, you'll have sine and cosine in these sequences as well. That'll also give it that positive negative effect. So, like for number 11, a sub 1 would be negative 1 to the 1 plus 1 power over 2 to the first minus 1. So that's, what's negative 1 squared? Positive 1. 1 over 1 would be 1. A sub 2 would be negative 1 to the third power over 2 squared minus 1. What is that? Negative 1 over 3. All I did was plug 2 in for the, I'm on number 11 right now. Yes, number 11. A sub 3. Well, actually, why don't you try a sub 3 and a sub 4 and see if you get them. Try to find a sub 3 and a sub 4 and see if you get the right thing. And I will also do that and see if we get the same thing. Also, if you were not able to take part 2 of the test yesterday, you can take that after the lesson today or tomorrow or just whenever, but it's up to you to come get that thing. Lynn, you got a sub 3 for me? I got 1/7. What number are you on, Flynn? Yeah. That's you sounded really confident in that. Yeah, we're on number 11. Sarah, you got a sub 3 for me? Do you need a pencil? Well, Jocelyn, do you have a sub 3 for me? What? 1 over 7 is what I got as well. And who has a sub 4? Ashton. That's what I got. I got a sub 3 was 1 over 7, and a sub 4 was negative 1 over 15. You just plug 3 in for n there any questions about where we're getting these things? No? Well, let's skip on ahead then. Okay. Before we start on this, if I said, this is actually something I'm going to use the exact example in my 2 days, so I'm going to go and use today. If I said you have $2 and you're going to double it every day, right? So what would we have tomorrow? 4. What would we have the next day? 8. Now, where did you get that 8? You took what and doubled it? 4. What you're actually using, what you used right now without even thinking about it, was a recursion formula. A recursion formula is where you use the previous answer and apply it to your pattern. So what was our whole equation? We were just taking 2 times a number, right? But what was that number? We were using the previous number, correct? So we had 2, then we had 4, then we took that previous answer and doubled it with our equation. We got 8, and we took that number and doubled it. That's all these are. These look like total Greek. People see these and freak out. They see inequalities. They see all these A subs. All this is saying, hey, the only point that they even have these on here is because, what did I say? I said you had $2 and doubled it, right? Well, you couldn't use that formula for the very first thing I gave you. You had to use a starting point. So all they're saying is, here's your starting point. Here's A sub 1. And then for every other term, every term greater than the second term, you're going to use this formula. So it's literally this simple. Number 13. A sub 1 is 7. It gives it to you. All recursion formulas have to give you a starting point. So, number 13, A sub 1 is 7. Then now all we have to do, all this mumbo jumbo here, just says add 5 to your previous term. So what would this next one be? What would the next one be? What would the next one be? That's all these recursion formulas are. A sub n minus 1 is the fancy schmancy mathy way of saying the previous term. Because if A sub n stands for our current term, then A sub n minus 1 is our previous term. And just a little outside the box question, what do you think our next term is going to be? No, it's not. I mean, what's the general way? If A sub n minus 1 is our previous term, what do you think our next what? That's right, A sub n plus 1. You're going to see these little labels used a few times. So, number 15, blah, 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 there's your first number, and what are you doing with that number from here on out? All you're doing is multiplying it by 4. People are like, whoa. You always subtract 1. No, that's just its way of saying, hey, use the previous term. 3 times 4, that times 4, that times 4, etc. So, number 15 would be 3, 12. Thank you, Ryan. 192. You try 17. Try 17. The first one's given to you. Then you just plug it in the previous formula for A sub n minus 1. Try numero. No. Why wouldn't you say 17? Cool. That's such an American answer. It is. We're an American.
Like you asked the question, why? And it's like, why not?
Here? This part right here? That's just saying, all that says is, you obviously can't use this formula until the second term. Because the first one gives you. That's all that says. Okay. Eeny, meeny, miny. Kevin. Kevin, what's my first term? Very good. What's my second term? That's what I got. Third term. Awesome. And fourth term? Very good. Does anybody get something else they'd like for us to take a look at? Talking time is over. Anybody get something else they'd like for us to take a look at? Right there. Are there any questions from this slide? Okay. Click. The general term of a sequence is given. Write the first four terms. Who can tell me what this thing is? You know, quick little aside. I was taking a task course in college, and one day my professor said something, and he's like, I didn't get it. He's like, you'll understand that in about 5 years. And one day I was teaching this, and all of a sudden, bang, I got it, because I was really stupid in college. And we were doing something that uses factorials, and he was just like I'm doing, like, hey, so what's the answer? And somebody asked him what the answer was. He goes, 6! I didn't get it. It took me like 5 years to get it. It took me forever. And then when I got it, I was like, oh, I felt so stupid because everybody else I'm sure got it much quicker. But literal years it took me to get that. Anyway, stay in school so you can get that in less than 5 years. Okay. Hey. Yeah, it doesn't matter who you were talking to. You're using the pronoun he. I don't know why I'm assuming that was me. I guess that's arrogance. It's always about him and me. Okay, in your calculator. Yes, you do, and I'm trying to show you where that is. If you hit math on your calculator, the math button, scroll all the way to the right to probability. The fourth one down is the factorial. And you can just punch that into the calculator. I'll show you how to actually calculate it as well, but you do have a button for it. Math, scroll all the way to the right, fourth one down. Yes, in fact, I think you have to use calculators the rest of the year. I will not be stopping you again. So, number 19, first four terms. 1 squared over 1 factorial is just 1. 2 squared over 2 factorial. Now again, I guess I didn't really say this. A factorial is where you just take that number and multiply it by every previous number. So like 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what a factorial is. Touche. So that would be 4 over 2, which is 2. 3 factorial is 3 squared over 9 over 6, which reduces to 3 halves. 4 squared over 4 factorial. Okay, I trust you. That's 16 over... Okay, 4 squared is 16. 4 factorial, 4 times 3 times 2 is 24. That does reduce to 2/3. So it's technology's fault. Your clicker's defective.
It was. I'm telling you.
It's not true. I'm actually going to make reference to that at the senior banquet. Are you going to that?
Yeah, I'm going.
Oh, good. I'm going to be mentioning that. Okay, anyway. Questions about how we got those 4 terms. What? Right here? That was this one. I was actually writing it out so people could see it. And this was just an example of the factorial. Try number 21. Try to find the first 4 terms of number 21. Order of operations. You do inside the parentheses, then you do the factorial, then you multiply. Factorial works like an exponent. It comes before multiplication and division. Right? I guess we'll find out. Someone crack open your book, section 10.1 in the answer section in the back. That way we can make sure we're right about that. I'm pretty sure it goes with exponents. Or someone could just do it. What's the map are you going to Marco, Nate, I'm going to split you guys up if you can't put Mamby-Pamby in back there.
You was hitting me in the neck.
Aww. He hit me.
He was like, I'm showing you how good costume is.
You think I'm bluffing, don't you? That I'll move you.
Huh? No, I'm not.
Deanna, what'd you get? What were your 4 terms? Okay, I'll wait. Why? Do you, okay. Let's see, do you get that you're just plugging 1 through 4 in for n? Of course you could, I guess the fastest way to do this would be just graph it and then trace 1, 2, 3, and 4. That's probably the fastest way to find the first 4 terms. If we just graph this thing, no, you don't, but you wouldn't have to punch it in every time. You could just trace it. X plus 1, factorial, graph, what feels like it's not there. Maybe it is there. Trace. 1, what? Interesting. What? Okay. For whatever reason, it's not showing up, but it's there. So your first term should have been 4. Your second term should have been, why do I keep doing this? 12. Down what you get for the third term? Let me see if that's what I got. And the fourth term? That's what I got. Questions about anything that we're doing? 240. Most of y'all are talking math, so I always like that. Evaluate each factorial. Ooh, these are fun. Here's why. Marco, I have a feeling you're going to be the kind of person that gets this really quick. Oh my thunder! Okay. All right. 17 factorial is 17 times 16 times 15 times 14. How far is he going to go with this before he just does dot, dot, dot? That's as far as I'm going to go. Times 2 times 1, right? Yes. 15 factorial is 15 times 14 times 13, dot, 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 times 2 times 1. Now, much as, was it Justin or Marco that said it? Oh. Look at everything that cancels. Because it's multiplication, you can do one term at a time. And everything's going to cancel except for what? 17 and 16. Okay. All right. Point is, when you're reducing factorials, the only thing that doesn't reduce is the difference in them. This one's too bigger than this one, so the top 2 terms is going to be all that doesn't reduce. Try 25. 25 is a little different. You may have to actually draw it out. Draw out the terms, 16, 2 factorial, and 14 factorial, and see what you get. No, wait. Draw out the terms. So that'd be 16 times 15 times 14 times 13, dot, dot, dot. Katie Beth, what's going to cancel here? All the way down. So what are we left with? That's right. 16 times 15 over 2, which is what, Marco? Thank you. Yes, you could just punch this straight into the calculator, but it is important you know how factorials work, because you're going to see them used in crazy ways. Now, the last one is a little more abstract. I'm going to give you all a second to look at that, and somebody raise your hand and explain to me what's going to happen. What exactly is going to happen? How is this one? What does a factorial do? It takes a number, it does what with it every time down? It multiplies it by what? That number minus 1, minus 1, minus 1, right? What is n plus 2 minus 1? N plus 1, that's right. The top is n plus 2 times n plus 1. What's n plus 1 minus 1? N. What's n minus 1? I kind of just said it. N minus 1. What's n minus 1 minus 1? N minus 2. And you would have to do that all the way down until you got to just 1, which you don't have to worry about. Just put a dot, dot, dot after it. Now, the bottom is going to be what? N minus 1, n minus 2, dot, dot, dot. What cancels?
Oh, it doesn't matter.
No, it doesn't. You're just doing a general thing. I'm sorry, what? Oh, it is defined. You're right. Well, yeah, but you're left with a 1. Yeah. So, all of this cancels with all of this, and all you're left with are those two terms, which I believe your book once spoiled. N plus 2 times n plus 1 is n squared plus... Very good. If you left it as n plus 2 times n plus 1, that's fine. But the book's going to have it like that, just FYI. Okay. So that's kind of an abstract way to use the factorial, using it with a non-concrete number. But you still just subtract 1 every time. It was already reduced. This was 240. Yeah. Okay. Those slides remaining. Oh, really? Is that where you think this is going? Are you ahead of me in the book, Ryan? Okay. The next slide, yes, are summations. Those crazy looking E thingies are nothing more than summations. All that is, here's how you read a summation. The E is actually the thing we're going to do last. You know how the first few slides we were doing first 4 terms? Well, like this would be an example of something with the first 4 terms. Here's your formula, except it uses I instead of N. And it says go from 1 to 4. It's the first 4 terms. You're going to plug in 1, 2, 3, and stop at 4. The bottom number is where you start. Top number is where you stop. Yes, you would. And what the E tells you to do is add them. That sigma tells you to add those together. So, number 31. Let's just do that one. Sure. Number 31. That's going to be 2 times 1 squared plus 2 times 2 squared plus 2 times 3 squared plus 2 times 4 squared. And then that's it, and you add them all together. Somebody tell me what that be. Okay, I shall wait.
44.
Can somebody verify that who's not sitting next to Marco? Thank you, Justin. 44. Summations. You just copied what he said. It was obvious. Questions about where that came from, how we got it, anything like that. Did you go one too far? Did you multiply before you squared on any of them?
No.
Well, let's see. Did you get 2 for your first number? Let's see. Okay, let's look at it. 2 times... Calm yourself, people. We'll look at it. 2 times 1 is 2. 2 times 4 is 8. 2 times 8 is 16. 2 times 16 is 32. What? Touche. Touche. So this would be 60. Nate was wrong. Oh, so you can take credit, but you can't take the blame, huh? You're a piggyback answerer. Yes. Yes. All we did was plug in 1 through 4 and for I. So 2 times 1 squared, and then 2 times 2. Basically, you do every number between 1 and 4. So 1 squared, 2 squared, 3 squared, 4. Try this one. Let's do a hard one. 41. Try 41. Fine. Hold on. I'm going. $41. Try it. Try it now. I don't know that you'll have to do this today, but interesting little factoid. 0 factorial is actually 1. I don't know why. Math people told me does, so I believe it. Math mafia. 0 factorial is 1 if you ever have to do anything like that. Ooh, like you would on 39. If we're not doing that. The fact that we need to really calculate. Do it. Oh. No, it's not me. You got it. Almost want to go together. I don't know. It takes all the 15 out of it. Just like everything goes back to it. Oh yeah, it does come into play. Please. I mean, what's going to happen is, what does that make it please? Like, I should have to give a please. What does that do with Kevin? All right. Again, to find the individual terms, you could just graph the equation and trace 1 through 5. You could do that. What was the first term? Who can tell me what just the first term was? What was the second term? What was the third term? Really? Is it this boring? Okay. Oh, because everything cancels. Ha, how about that? So you get 15? Now, let's step it up a notch. What if I said... What if I said add the first 500 terms? And you'd be thinking, Mr. Crawford, I hate you. But I'm going to show you a way to do it on your calculator. Here's a way you can do a summation on your calculator. And this is going to be kind of complicated, so it's important you pay attention. Okay. Well, let me make sure I remember real quick. Yeah, I do. Okay. First thing you need to do, hit second stat. Second stat. Scroll all the way to the right and go down to sum. We are finding a sum. Enter. It's the second. It's right under delete. Second stats. Scroll all the way to the right. Click sum. Next thing you do. Second stats. Scroll only one to the right, and go down to sequence. Sequence. Oh, well, I'll change it. Okay. Sum sequence. Now, there are 4 things your calculator needs to know. Well, technically 5, but really only 4. First, what is the sequence? It needs to know what the formula is. So being very mindful of your parentheses, and it's the parentheses issue that makes the whole thing not even worth it. Yeah.
Oh, you got to put it in the gray one. Oh, okay. Yeah, these are actually better. So, like, what I'm about to do with a whole bunch of commas and parentheses, you can do something. Yeah. So, like, you all,
First thing you guys need to do is just punch in the formula. All right, for everybody with a Mortal calculator, we have to punch in the formula. So, first thing, x factorial. Obviously, we can't use I. X factorial. Close the numerator. Divided by. All I'm doing is plugging in the formula. I ain't even doing nothing else. What? What, the voice? Thinking I might try to be a star in horror movies one day. Okay, now all I've done is punch in the formula. X factorial over x minus 1. Now notice, you have to double, now unless you have a superhuman calculator, you have to double enter into the denominator. Because one of them is going to group the x minus 1, but you also need one of them to make sure that the factorial is just in the denominator. So you have to double group it.
what did you put on the end of that?
One second. No. First off, see, if you don't open a parentheses, it's going to close right there. And if you get to open that parentheses, that's how I have to kind of do it. Then you need to open another one. That's going to be minus 1. Close the denominator. Yeah. Then if you have a gray one, what? The Sigma thing? That's what Katie Beth has. I don't think it'll work on ours though.
It doesn't work.
Yeah. Alright, so anyway. Okay. First thing you need to know is your formula. Second thing, it needed to know where to start. So we started at 1. Second thing it needs to know is where to stop. Now I'm just going to go to 5 because that's the one we already did. So on this particular one we just did, we went from 1 to 5. Next thing it needs to know, although this is stupid, it needs to know what the variable is. Well, obviously it's x. So you do comma 1, comma 5, comma x. And the last thing it needs to know, everything that we do, we're what? Going up by values of 1, right? 1, 2, 3, 4, 5, etc. There are technically, you could go up by 5, you can go up by 3. So it needs to know your step size. In this class, your step size will always be 1. So you always have to finish with a comma 1. What? Hold on. 1, 5, x. Oh, I think variable comes first. X. See, I don't really use this that often. 1. Here we go. The x comes first. Variable, start, end, step. There you go. 15, which is what we got. Now, you might be thinking, whoa, not worth it. But you may have one on your test that asks for like 30 terms, all that is good. Accidentally had the 1 first last time. I'll come look at your individual problem in just a second to answer your question, Sarah. You do your formula, right? Then you have to declare your variable, starting point, ending point, and then step size. Step size, which is always going to be 1 in the class. Like, always, yeah. Okay. Oh, okay. Rule of thumb, for every parenthesis you open, you have to put a figure. So if you open 1, 2, 3, 4, 5 parentheses, you want to put a switch. Between somewhere you have limited. That one looks good. You didn't put a because you have more close parentheses, you only open 3, but you close 4. So it's like, whoa, I'm way confused. You should have just a second. Okay. Your actual formula goes here. Everything's contained in it. So different. What? Thank you. There is also an excellent write-up of how to do this on page 954. You actually, you don't need a print. Any other calculator questions? You don't even have to use it. You see how the biggest problem we've had all day is calculator based? That's why I don't use calculator. Okay, your brain doesn't have these problems. Your brain's not going to be like, syntax error. You don't care. That's the beauty of a human brain. All right. Last but not least. These are actually kind of fun, but I'll tell you what, I'm going to make them bonus because it's not really hugely relevant. On these problems, and I'll show you one example, and I'm going to cut it loose. These problems, you have to take the formula and figure out what the summation would be. So let me show you one example. I'm not going to take questions on it because it's only bonus, but for like number 49, for instance. What is happening on the top? Yeah, just going up by 1. And I'm just going to write the answer up here and then we can discuss it. So that would be like, hold on. That would be the answer to number 49. You don't have to do them. Now, but here's the thing about these. You're going to come up with one you think is going to be perfect. Okay? I only know this because I've been doing this a long time. The first few times you do this, you're going to come up with one that's going to look awesome. But as you start plugging in 1, 2, 3, it might work for the first term, the second term, the third term, but not the fourth term, not the fifth term, not the last term. And you may have to tweak them a little. That's the natural part of the process. So don't think, oh, I'm not getting it. You may have to tweak it. And you need to check it. If I plug 1 into this, that's 1 over 2. Check. If I plug 2 into this, 2 over 3. Check. If I plug 14 into this, 14 over 15. Check. So I'm confident that it's right. You have to check every term. Just because the first and second terms work doesn't mean the whole thing works. But they're just bonus. Don't even worry about it. Okay. But I'm changing this. No, wait, hold on. That's still wrong. There we go.